Good morning everyone. Today let us continue the same unit 2, that is knowledge representation and reasoning. So here we completed this knowledge based agent, propositional logic, inference and the first order logic or predicate logic. Today in this session let us discuss about the resolution. So what is this resolution? Let us discuss this with a simple example. So what do you mean by this resolution? The resolution inference rule takes two premises in the form of two classes. That classes may be ARX and BR negation X, and gives the class ARB as a conclusion. So from these two classes, how we got the conclusion as ARB? For that we need to follow some rules while we are using this resolution. So this resolution proof technique works in this way. The very first is we are going to select two classes that contain conflicting terms, and we are going to combine those two classes and cancel out the conflicting term. So here these 3 points, here we are showing it very clearly. So see here, we are taking these two classes, and when there is a conflicting term, that we are going to combine. So when we combine ARX and BRX, this X and negation X gets cancelled. That's why the conclusion we are going to get it as a ARB as a conclusion. So this is what the procedure to be followed to make use of this resolution. Here one more example. This example I already explained. One more time I am explaining. See here, these are the set of premises given. The very first thing to find out the resolution is we have to convert it into a clausal form. So to convert it into clausal form, whenever we have this conditional, that we have to convert it into conjunction form. So we know that P conditional Q is negation P R Q. In that way, this P conditional Q is negation P R Q R, and S conditional negation R is negation S R negation R. And whenever we have P and S, that is A and B, we can write it as A and we can also write it as B. So in that way we have written P and S. So these four classes, we have made these three set of premises into converted into four set of classes. Now as per this point, we are going to select two clauses that contain the conflicting terms. So here first let us combine two clauses such that there will be a conflicting term. Suppose let us take this C1 and C2. See here, is there any conflicting term? Yes, we have R and negation R. So the resultant will be negation P R Q R negation S. So that will be resultant of this class phi. Okay. Now let us combine this class phi, that is negation P R Q R negation S, okay, with another class S. Okay. So see here. So this resultant with C phi and C3, the C phi and C3 P, okay, we have negation P here and P here. So we are going to cancel those terms. The resultant will be, you will be getting Q, okay, that is QR negation S. So QR negation S. Next, from this we got clause 6. From clause 6 and clause 4, okay, we have a conflicting term negation S and S. So the resultant will be Q. So therefore the conclusion for this particular set of premises is the Q. So this is how for a simple example. Let us discuss one more example. Given a facts, from that facts you have to prove that the conclusion is a valid conclusion using resolution refutation principle. Let us see this. Let us see that example, how a facts can be converted into class form and how with the help of resolution we are going to find out the conclusion. So these are some of the facts related to resolution. Now these are the facts given, and from these facts they are asking us to prove this one. So how first these facts are going to be converted into a symbolic form using this resolution. The very first one is Ramu likes all kinds of food. Apple and chicken are food. Anything anyone eats and not killed is a food. Anil eats peanuts and still alive. Sita eats everything that Anil eats. So from these facts they are asking us to prove that Ramu likes peanuts. That is, likes Ramu, comma, peanut. So these are the facts given. We have to prove that this particular conclusion is a valid conclusion from the set of given facts. So when we make use of this resolution and when we want to prove something like this, we need to follow some steps. Let us first discuss what are the steps to be followed to find that whether a conclusion is a valid conclusion or not. For that, the very first step is we are going to negate the conclusion statement. The first step is we are going to negate the conclusion statement. Okay. And second one is convert given facts into FOL. Convert given facts into FOL. That is first order logic. And third one, we are going to convert this first order logic into convert FOL into CNF, that is conjunctive normal form. Then the fourth one is we are going to draw the resolution graph. Okay, so these are the 4 steps to be followed. The very first step is we are going to negate the conclusion statement. So here what they have given, Ramu likes peanuts. We have to make that negation of the conclusion as Ramu does not like peanuts. That is simply we can keep it as negation, that is not likes Ramu comma peanuts. And second one is we are going to convert these facts into first order logic. And then the third one is converting this first order logic into CNF. And the fourth step is we are going to draw the resolution graph. From that graph we have to derive a contradiction. Then we can say that this particular conclusion is a valid conclusion from the given set of statements. So let us, so first step we already converted, that we have negated the conclusion statement. Then the second one is converting this particular facts into FOL. Let us see that. Second one. Second step is we are going to converting the facts into first order logic. Okay. So here Ramu likes all kinds of food. The first statement is Ramu likes all kinds of food. So whenever we get all, we know that it is a universal quantifier. So it is represented something like this. For all X, what we are saying, all kinds of food. Food, comma X. Then it is likes Ramu, comma X. So who is going to like the food, all kinds of food? Ramu is going to like the all kinds of food. So it is food X likes Ramu, comma X. So in this way we are going to convert this particular fact into first order logic. Second one, apple and chicken are food. So simply we can write it as food equal to apple and food is also a chicken. Okay, this is the second fact converted into first order logic. Okay. Next one, anything anyone eats and not killed is food. So anything is any food, anyone is any, it may belongs to person. So we can write it as anyone is X, anything is Y. Okay, and then what we are saying here, eats, anything anyone eats, that is eats X comma Y. Y is going to eat X and is not killed. And not killed, just simply say that negation killed of Y. Okay, killed, that is killed, that is X is food of Y. Okay, so anything anyone eats X comma Y and not killed is simply negation killed of that X and food is Y. Why? Because we are saying that anyone is X, anything is food. So that's why killed we are saying as X and food as Y. Okay, so this is how we are going to convert this particular fact into first order logic for this particular statement. What is the next one? Anil eats peanuts and still alive. Okay, that is for all X eats Anil comma peanuts. Okay, and we are saying that still alive. Who is alive? Anil is alive. Okay, and still alive. So see here, Anil eats peanuts, that is eats Anil comma peanuts and just made it as and symbol and still alive. So alive comma who is alive? Anil is alive. Okay, this is the fourth fact. Then Sita eats everything that Anil eats. That is for all X. C eats, for all x we can say that, okay, Sita eats everything that Anil eats. So eats Anil comma peanuts, okay, then who is going to eat? Sita comma x, okay. So in this way we are going to convert this particular facts into first order logic. So to prove this particular conclusion, actually we need some additional predicates. Just I'm writing 2 more additional predicates so that we are going to derive this particular conclusion from this set of facts. So let us write 2 more predicates for this. That is negation killed of x, that is alive of x, and then for all x, okay, alive of x given negation killed of x, okay. So these are the how the given facts we are going to convert it into first order logic. So we will go for the next step, that is how we are going to convert the first order logic into the conjunction normal form. So the next step is converting this first order logic into CNF. So before converting this first order logic into CNF, we need to follow some rules before converting this first order logic into CNF. Let us see what are the rules to be followed to convert this first order logic into conjunctive normal form. So the very first rule is we are going to eliminate conditionals and biconditionals. In the very first class of propositional logic, I told you one formula, that is P conditional Q is equivalent to negation P R Q. That means whenever we have a condition in a particular formula, okay, in any first order logic, we need to convert it into equivalent formula. That is P conditional Q can be replaced by negation P R Q. And one more is P biconditional Q, which is given as P conditional Q and Q conditional P. So in this way, first we are going to eliminate this conditionals and biconditionals. So with conditionals, we can't prove the conclusion. So we need to convert it into conjunctive normal form with the help of these 2 formulas. And next one is whenever we have a negation, okay, that should be moved towards inward. That is, suppose there is a formula something like this, negation P and Q. So how we are going to write? So that negation should be applied inside variables also. That is negation P and will become R and it will become negation Q. And suppose if it is negation P R Q, okay, then we can apply this negation inwards. It will become negation P, R will become and it will become negation Q. And if it is negation of negation P, okay, then negation gets cancelled, the formula will be equivalent to P. So in this way, these rules we have to follow. And whenever you see any universal quantifier, just we are going to drop the universal quantifier. So these are the 3 main rules to be followed when we are converting first order logic into CNF.